Okay, so we just derived then at the end of this motion, this first epoch of motion, that the speed was 90 meters per second. So we had an acceleration of 3 meters per second squared. And now we can fill in the level at which the velocity will be constant, which was 90 meters per second. Now I want to point out there's another way, now that we know what this velocity is, to calculate the distance that we traveled during this first epoch, which is to find the area under the velocity versus time graph here. And so we know that we derived last time that the displacement is equal to the area under the velocity versus time curve. And so that's going to be equal to 1/2 times the final velocity minus the initial velocity times the time that we travel. And so we know that our initial velocity is equal to 0. And so we can write this as 1/2. Now that we know the final velocity, we can write this as 90 meters per second. And we travel for 30 seconds. And so we can use this to calculate how far we actually went. And if we multiply all of this out, we get the same 1,350 meters that we calculated on the previous slide using our kinematic equations. So for constant acceleration, this all works out really well. So that's another way to find the distance for this first part of the epoch. So now that we've explained the first part of the motion, we know where we ended. So the final position of the first part was 1,350 meters. And we know what the final velocity at the end of the first part was. So velocity is equal to 90 meters per second. For the second part of the motion, so let's put a big capital 2 here that we're talking about the second part of the motion, the acceleration is equal to 0. So now we can go back to our kinematic equations and use those to figure out how far we go during the second half of the motion. So we have these things described already. We can write that the final position after the end of the second epoch is equal to the initial position at the start of the second epoch plus my initial velocity times time. We can leave off the 1/2 at squared part because the acceleration is 0. And so this becomes equal to 1,350 meters. That's my original position, plus 90 meters per second times the time of the second part of the motion, which is again 30 seconds. And so the total distance that I travel is equal to 1,350 plus 90 times 30. So all told, this is 1,350 plus 2,700. So the total distance that I traveled then is equal to 4,050 meters. So that is actually the answer to the problem. That's the total distance that I've traveled. So that's one way of getting the answer. Another way of getting the answer is, again, we can look at the area under the velocity versus time graph, use that to calculate the area here that tells us how far we go in the second epoch, and then we can add that distance to the original position of 1,350 meters that we had at the start. And so the area of that rectangle is equal to the velocity that we had during this epoch times the amount of time that I've traveled. And so again, this is going to tell me how far I've gone during that time. And so we can write this out. This is equal to 90 meters per second times 30 seconds. And so the distance that I've traveled during the time when the velocity is constant here in this rectangle is 2,700 meters. And so if I add that to 1,350, you can see that this is also 2,700 meters here. I'm going to get exactly the same answer that I had before, which is 4,050 meters. So that is the total distance that the motorcycle travels during the sum of the two epochs of its motion.